Well, we are at week 7 of this semester, almost halfway. So I hope you're enjoying watching the videos and listening to some other podcasts or information regarding endurance performance. Let's continue with our kinetic analysis. We've done swimming, we've done cycling, and now we are on the run segment of a triathlon. So now this week 7, we'll do run kinetics. Let me go through the README first document. And let me zoom in a bit so it's a little easier to see. Okay, so the videos I want you to watch this week include the run kinetic analysis. So again, our kinetic analysis, we identify forces acting on the object during movement. In this case, we're going to be talking about running. And I go through sort of a big picture perspective of run kinetics. Make sure you download those notes, make sure that you can keep track of them. And hopefully you picked up by now, I just scanned the notes that I write during the presentation. So hopefully that makes sense. So then I go more into detail on the vertical ground reaction force, where we're specifically looking at one dimension for running. And that's a very critical dimension to look at. Lots of research on the vertical ground reaction force during running because it's the greatest magnitude of the 3 dimensions. We can see forces 2 times, maybe 3 times body weight, depending on how fast we're running. Whereas the forces in the anterior posterior direction, they're fractions of body weight, and in the medial lateral direction, even smaller. And in the medial lateral directions, they're small because you're running pretty much forward. Now, if you're going to do a turn or change directions or try to avoid an object, well, then the medial lateral uh, ground reaction force becomes really important. And in fact, there's lots of neat research on that component when you're looking at cutting maneuvers where you're trying to change directions quickly. But endurance runners are pretty much just running straight. And so we'll focus on 2 dimensions in this semester, being the vertical, and then the next presentation is on more details on the horizontal ground reaction force, specifically the anterior posterior ground reaction force. So first presentation, sort of the big picture kinetic analysis. Second is more dialing into vertical ground reaction force. And then the third, the anterior posterior ground reaction force. The next presentation is sort of more of a almost a lab exercise where I use the portable force platforms and I do a number of movements on it. I think I may have actually shown this one in a previous module. If you've already seen it, that's great. And if you have, make sure to go back and look specifically at the locomotion portions of the video, because now we're really trying to connect the ability to do the math and determine what the ground reaction force should look like. And that's what those first 3 presentations are about. And then measure ground reaction forces and see if it matches with what we expect. And so what I really want you to be able to do in this class is not necessarily the math behind, integrating or taking derivatives, but more so really thinking about doing a kinetic analysis. What happens when you add up the forces, which tells you acceleration? What does that acceleration mean? How do you interpret that? All right. So the ground reaction force example, I actually do some squat maneuvers, some jumping, and those actually I do reference the other videos I've done, which I showed as being an option last week, and that's fine. There's still an option, but in that ground reaction force example, really zero in on the locomotion components of starting, stopping, going constant, things like that, and hopefully that will help you understand the first 3 presentations a little better, because it's hard to deal with forces because we can't see the force unless we measure it. And then, we try to understand our kinematics by looking at the kinetics happening on the object. Okay, let's see, what do I have? I've got ground reaction force running vertical, then I go into more detail on both of those. Um, yeah, go into more detail on each of them again. So actually, I'll go back and double check. I was watching the videos before posting this. I'll double check that I didn't, that it's unique information on each of those. But what I'm really trying to do is give you really good biomechanic information on two dimensions, vertical and anterior posterior. The presentations shaded in gray are those more applied presentations. And what I'm looking for you to do is to watch these and then see if you're understanding how we're using forces to understand something. Maybe, understand shoe design. And that's what the running shoe and the impact testing presentations are about, is, really trying to understand the biomechanics behind running shoes. Now, from the other class, physiology of endurance performance, we'll talk about physiology of running shoes. So I touch on it a little bit in these presentations as well. Then I have a presentation with Hoka where I had some, almost like a podcast, but we had a group of us meet with a couple of Hoka reps and we talked about their shoes. Now, if you don't know Hoka, Hoka is a brand of shoes that is considered maximum cushioning, so real thick insoles, or excuse me, midsoles. So actually, here's a pair right here. Okay, I'm not sponsored by Hoka. I don't have anything to do with them. But what's interesting is probably about 10 years ago, the running movement went more towards barefoot running or even minimalist running. And then the pendulum swung quickly back from that type of movement where you're having very little protection on the feet to a shoe like this, which was real extreme protection. So we talk about that in that video, and we talk about innovating. And I know several of you may have an interest in working for a company like Hoka or Nike or Reebok. And in fact, I actually encourage you to go to those websites and look at the career postings that they have. They'll post job openings. And I always encourage you to go and look for that job now, even if you can't take it, because what it will do is it will show you the skills necessary to get the type of job you really want. And then you try to pick up those skills while you're doing your undergrad degree. Okay, and then Mr. Gerard and myself actually had a really good podcast that was really good for this class. And last Friday, we talked about run metrics. And we talked a lot about stride length, stride frequency. Actually talk about leg stiffness, which I don't get too much into in this semester. So it would be good for you to even hear how we are using all the biomechanical terms that we're going through here. We talk about forces. We talk about running force that he was able to measure using a wearable tech device. And ultimately, we'll talk about running power, and we talk about that as well. So that's a really good podcast to listen to see how we are using biomechanics to really help someone run faster or further. And if you watch that, again, there's not going to be questions on a test from that podcast, but to understand the questions on the test, you should be able to understand how we are using terms that I'm going through in those first series of presentations. So if you watch that podcast and it just doesn't seem to make sense at all, go back and watch the ground reaction force and the kinetic analysis presentations, and that will give you some more granular detail to work on. Let's see. I think that's sort of all I want to go through with this. I hope you're enjoying the videos, enjoying the learning, and hopefully you're getting out for a run or a walk or a bike ride, or maybe even a swim if you have access to a pool. Okay, thanks everybody. Have a good week.